Hey everyone! Today I'll be showing what decorators are in Python. If we have a look at what Google has to say about it, we see that, by definition, a decorator is a design pattern in Python that allows the user to add new functionality to an existing object without modifying its structure. But what does that even mean? Trying to understand what a decorator is by its definition can be a bit confusing. I find it easier to look at an example. So let's demonstrate what a decorator is by showing you an example in Python. We will be making a decorator that measures the execution time of any function. Let's create a function called myDecorator that takes a function f as input. Let's import callable from the typing library and type annotate f as callable. We create an inner function inside our decorator called wrapper, which takes as arguments args and quarks. We then execute the function f inside the wrapper, passing args and quarks to it. We can now finish a basic template for our decorator by returning the wrapper. Let's now create a function to which we can apply our decorator. Let's create a function called listLookup, which takes an item and a list as input arguments, and it returns if the item is found inside the list. We can then apply our decorator to the listLookup function by writing @myDecorator in front of the lookup function. Let's add a print statement before executing f. Let's add another after executing f. Let's now perform the listLookup function to see the effect of the decorator. As you can see, before and after is being printed, but we don't see the result of the function f or the listLookup function. Let's add a print statement to show the results of f. Let's execute the listLookup function again. As you can see in the output, we now see before and after, and in between we see the output of our function. So as you can see, applying myDecorator to our listLookup function allows us to execute some code before and after every listLookup execution. Let's now make the wrapper return the result of the function f, so the result can be used on line 19, where the function is executed. Let's remove the old print statements from the decorator and import the time library so we can record the duration of a function's execution. Inside our wrapper, let's create a variable s and record the time before executing f. Let's then create a variable and to record the time after executing f. We can then calculate and print the duration of the function execution and print the function name alongside it. Let's execute our listLookup function again to see the effect of our new decorator. In the output, we see that function listLookup has a duration of 0.001 seconds. Awesome! We can now calculate the duration that our functions take to execute. Let's see how easy it is to apply our decorator to a new function to be able to compare the execution duration of two functions. We create a new function called hashTableLookup, which takes in an item and a hash table in which it should look up the item. We then try to find the item in the hash table, and if it doesn't fail, we return true. Otherwise, when an exception is thrown if the item is not found, we return false. Now we can easily time the duration of our hashTableLookup function by adding our decorator to it. Let's change this to result1, create result2, and call our hashTableLookup function. Let's now execute our program again to compare the execution durations of both these functions. As you can see, function listLookup takes the same 0.001 seconds as it did before, and the function hashTableLookup takes 0 seconds. How awesome is that? Now we can easily time any functions we want. I hope this video helped you in understanding what decorators are and how to use them. If it did, please leave a like, and if you want to see more content like this, it's appreciated if you would subscribe. Have a nice day. Peace.